Jai Shri Gurudev. Good morning to everyone students. In this class we are going to study laws of chemical combination. Laws of chemical combination. Here the atoms is are present in an element. Our element is consist of an atom. Those elements combine together to form a compounds. Is governed by five basic laws. That is the atoms of elements combine together to form compounds. So atoms of an element is consist of atoms. These elements combine together to form a compound is governed by five basic laws. Those we are studied one by one here. The five basic laws are: the first one is law of conservation of mass. Then second one, law of definite proportion or fixed proportion. And the third one is law of multiple proportion. The fourth one is Gay-Lussac law, and the last means fifth one is Avogadro's laws. These five laws says only about of an atoms of an element. Those we are studied here. Now take the first basic law is law of conservation of mass. This is the first basic law, that is law of conservation of mass. This law of conservation of mass is proposed by the scientist Lavoisier. This law of conservation of mass is proposed by the scientist Lavoisier. The Lavoisier is a scientist. He only proposed the law of conservation of mass. This law states that mass of an atom is neither be created nor be destroyed, but can be converted into one form to another form. So very very important and simple one. This law of conservation of mass says that mass of an atom is neither be created nor be destroyed. But can be converted one form to other form. This is the statement of law of conservation of mass. That is, the mass of an atom is neither be created nor be destroyed, but we can convert one form to another form. Example, take water. That is, we are taking liquid water. Take its 18 gram. Its molecular mass is 18. So let's take 18 gram. Either take 20 grams. Any, just to take a quantity. Let's take 18 grams of water we are taking, liquid, which can be converted into one form to another form, which can also be converted into solid ice. That is water, we call solid ice. Here the grams is 18 only, but here this is liquid, we call water. This water can be converted into what? Ice. Okay. This water on heating is converted into ice. After water and cooling, you get a solid ice. After heating solid ice, you get water, that is liquid water. They both having same weight, that is 18 gram only, but the state is changes. Even changing state, the quantity of water doesn't changes. It remains same. That only says that the law of conservation of mass, that is, the mass of an atom is neither be created, we can't create, and nor be destroyed. We can't destroy. ಅಂದ್ರೆ ನಾವು ಹೊಸದಾಗಿ ಉತ್ಪತ್ತಿ ಮಾಡಕ್ಕೂ ಆಗೋದಿಲ್ಲ, ಅದನ್ನ ಹಾಳು ಮಾಡಕ್ಕೂ ಆಗೋದಿಲ್ಲ. ಬಟ್ ವಿ ಕ್ಯಾನ್ ಚೇಂಜ್ ಒನ್ ಫಾರ್ಮ್ ಟು ಅನದರ್ ಫಾರ್ಮ್. ಅಂದ್ರೆ ಒಂದು ರೀತಿಯಿಂದ, ಅಂದ್ರೆ ಒಂದು ಸ್ಟೇಟ್ ಇಂದ ಇನ್ನೊಂದು ಸ್ಟೇಟ್ ಯು ಕ್ಯಾನ್ ಚೇಂಜ್ ಒನ್ ಸ್ಟೇಟ್ ಟು Understand, this is the law of conservation of mass. This is the first law which is proposed by the scientist Lavoisier. Now take second law. The second law is law of definite proportion and fixed proportion. Second law, law of definite proportion or fixed proportion. Fixed proportion. This is the second basic law. Law of definite proportion or fixed proportion. This law of definite proportion or fixed proportion is proposed by the scientist Joseph Proust. This law is proposed by the scientist Joseph Proust. Joseph Proust is the scientist. He only proposed the second law, that is law of definite proportion or fixed proportion. This is very important for the purpose of exam. Definitely they ask for 2 marks. This law states that a given compound always containing exactly the same proportion of elements by its weight. This law states that, means law of definite proportion states that a given compound containing always the exact exact proportion of elements by its weight. That is right. A given compound containing, this law states that a given compound contains exactly the same proportion of elements by its weight. This law states that a given compound containing exactly the same proportion of an element by its weight is called law of definite proportion or multiple proportion. So observe here, take example, cupric carbonate. Cupric carbonate, its molecular formula is CuCO3. This is the molecular formula cupric carbonate. Here the second law, definite proportion, is says that a given compound contains exactly the proportion of elements by its weight. Proportion of elements always contain exactly the proportion of elements by its weight. ಅಂದ್ರೆ ಎಷ್ಟು ಕೊಟ್ಟಿರ್ತೀವೋ ನಾವು ಒಂದು ಕಾಂಪೌಂಡ್ ಅನ್ನ ಅದರ ವೆಯ್ಟ್ ಏನಿರುತ್ತೋ, ಈ ಎಲಿಮೆಂಟ್ಸ್ ನ ವೆಯ್ಟ್ ಏನಿರುತ್ತೋ ಸೇಮ್ ಅದೇ ಪ್ರಪೋರ್ಷನ್ ಇರುತ್ತೆ ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಅಬ್ಸರ್ವ್ this copper carbonate, that is cupric carbonate or copper to carbonate, this can be synthesized or it can be made by both naturally and artificially. It means naturally and synthetic. So take natural and synthetic. Natural and synthetic. Natural sample and synthetic sample. Now observe here there is 2 samples of copper to carbonate or cupric carbonate. Here we are taking cupric carbonate CuCO3. This is the compound, and what are the elements present in this compound? One is copper and another is carbon, then the third one is oxygen. These are the 3 elements present in this cupric carbonate. Now this copper is present in the percentage 51.35%. This copper containing 51.35%. Right here the copper percentage and the carbon percentage and oxygen percentage. Now the copper percentage is 9.74, Then the oxygen percentage after removing these two percentage is 38.91. These are the percentage of an element present in the natural sample, and the artificial or the synthetic sample also containing same percentage of these elements. That only says that this law of definite proportion or fixed proportion. Here the synthetic sample also containing 51.35 percentage of copper and 9.74 percentage of carbon and 38.91 percentage of oxygen. Okay, I hope you understand, students. Here listen, the law of definite proportion or fixed proportion. It says that a given compound containing always exactly the same proportion of elements by its weight. That is, this is the compound is always containing exactly means same proportions by its elements of weight. These elements weight here given in the form of percentage. It is present in both the cases, that is natural case and synthetic case is same. That is only the law of definite proportion and fixed proportion says. Now going to third law. The third law is law of multiple proportion. This is definite. The word itself says definite. Definite means fixed, same. That is only called fixed proportion. These are the fixed quantities in the same sample, but is made by two ways. One is synthetic and natural. Okay. Then take third one. Then the third law is law of multiple proportion. Third one, law of multiple proportion. The previous one is fixed or definite proportion. Now law of multiple proportion. This is the third law. This is also very important. Either they ask multiple proportion or fixed proportions. Both are very important. Now this law of multiple proportion is proposed by the scientist Dalton. It is proposed by the scientist Dalton. Scientist Dalton is only proposed by the law of multiple proportion. It states that law of multiple proportion two elements is combined together. It states that two elements can combine together to form a compound, and masses of one element is combined with the masses of or fixed mass of another element. The ratio of an element is simple whole number. It's called law of multiple proportion. Now observe, after writing the statement and taking example, you know what is mean by law of multiple proportion. Now write the statement. It states that elements of are two different elements. It states that take two different elements can combine to form compounds, and the masses of one element. The masses of one element is combined with masses of or fixed mass of other element. The ratio is simple whole number. Simple whole number. This is the statement of multiple proportion, that is law of multiple proportion. Here observe, it states that very simple one. Listen, it states that two different elements can combine. Two different elements. Let's take two different elements A and B. These are the two different elements. These two are combined together. These two are combined together. Now these two are combined together to form a compound AB. To form a compound AB. Then the masses of one element. The masses of one element. Let's take A. The masses of one element is combined with the fixed mass of another element. Let's take B. This is the fixed mass. And this is variable. Let's take the masses of one element. Here we are writing masses. It means the element has more than one mass. More than one mass means variable masses. But the B has only fixed mass. That is only one mass. That is the masses of an element A. That is masses of one element combined together. Combined with fixed mass of another element to fixed mass of another element. The ratio is simple whole number. That is, we are varying mass of an element A and we combine with the fixed mass of an B. You get a compound of the type A to B. A to B. You get this type. Okay. Now let's take the mass of an element A is 2. And the mass of an element B is how much now? 4. It becomes exactly 4. And the mass of B is take 1. And here also become 1 only. After these two elements, means the element having atomic mass 2 and 4, its ratio is simple whole number. Here there is 2 and 4. 2 is to 4. And its ratio is simple whole number. Means again it can be reduced in the form of 1 is to 2. So you can write like that now. 2 is to 4 can also be written 1 is to 2 because it can be divided by 2. Divided by 2, you get or multiplied by 1 by 2, you get same number. So that only says that again the ratio is simple whole number. This is the law of multiple proportion. Okay, what it says that two elements are combined. That is, two different elements can combine together to form a compound. The masses of one element is combined with the fixed mass of other element. The ratio is simple whole number. This is the statement of multiple proportion, and they ask again to explain with an example. They ask to explain with an example. Now take water. Example, take water, that is hydrogen is combined with oxygen. Hydrogen H2 is combined with oxygen, it gives water H2O. Let's take half oxygen. Okay, now H2 is one element and oxygen is another element. We get a compound water. Now again, the masses of other element. Now vary the mass of oxygen. Here we are taking off oxygen. Now take one oxygen, that is right volt. Now we are varying the mass of the oxygen and fix the mass of a hydrogen. Hydrogen in a fix ಮಾಡ್ಕೊಳ್ಳಿ hydrogen mass, oxygen mass ನ vary ಮಾಡ್ಕೊಳ್ಳಿ. Vary ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಎಷ್ಟು ಮಾಡಿದ್ವಿ? half ಇರೋದನ್ನ 1 ಮಾಡಿದ್ವಿ. That is oxygen plus hydrogen. So we are varying the mass of oxygen and mass of the hydrogen is fixing. Now you get again hydrogen peroxide H2O2. Here you get H2O, here you get water. This is water and this is hydrogen peroxide. Hydrogen peroxide. Hydrogen peroxide. Now observe here the hydrogen has atomic number 1. Now here we are taking 2 atoms, so its atomic number is 2. Now 2. And oxygen, we are taking only 1 oxygen. Its atomic mass is 12. That is, sorry, not 12, 16 double times. And the water, we get 18 for water. And similarly, take hydrogen, it is fixed 2. And oxygen, we are taking 4 to 1 molecule, therefore it becomes 32. Okay, here there is only 1 oxygen, but here 2 oxygens. And here hydrogen peroxide, 1 oxygen is extra. For 1 oxygen here there is 32. Sorry, oxygen for 16. So total you get 48 for here hydrogen peroxide. Get 48. 48 are what? right? For oxygen, how much? For water, 18, and one more oxygen is 16. Therefore, get 4 plus 34. 34. This is the masses of these hydrogen, oxygen, and water, and hydrogen peroxide. So observe here, these are the variable masses. We are varying only for oxygen, that is 16 divided by 32. In the water ratio, you get 16 ones are 16 twos, that is 1 by 2. It means 1:2 ratio. This is a simple whole number, right? That only says that after varying the masses of one element and reacts with fixed mass of another element, this ratio is simple. Okay, this is the third law, that is law of multiple proportion. Now take fourth one. So the next law is, that is fourth law, Gay-Lussac law of gaseous volume. The fourth law is Gay-Lussac law of gaseous volume. This Gay-Lussac law is proposed by the scientist Gay-Lussac. Gay-Lussac is the scientist name. Gay-Lussac is the scientist. He only proposed this fourth law about gaseous volumes, that is volume of gases. He states that the Gay-Lussac says that when gases are combined or produced in a chemical reaction, when combined or produced in a chemical reaction, by do so in a simple ratio of volume provided all gases are at same temperature and pressure. That is, when two gases are combined or produce a chemical reaction, they do so in the simple ratio of volume provided all gases are at same temperature and pressure. So now observe, to understand the definition of this fourth law, that is Gay-Lussac law, take example, hydrogen is a one gas and oxygen is one more gas. Now these two are react together to form water, that is H2O. Take off oxygen, you get water, H2O. So now this is hydrogen, which is combined with oxygen and gives water. Okay. Now write in the word form or write in chemical equation. Now hydrogen is reacting with oxygen at same temperature and pressure to get a water. Let's take the 100 ml of hydrogen. 100 ml of hydrogen, that is volume we are taking, take 100 cm3. Always you know the volume is measured in terms of centimeter cube or ml. Either you write centimeter cube or ml, means milliliter. Let's take hydrogen is 100 centimeter cube and take oxygen is 50 centimeter cube. And after these two are reacting, you get the 100 centimeter cube only, not you get 150 centimeter cube. The volume is same at a different, at same temperature and pressure. That and the ratio is give simple whole number. Now take here, you get water is 100 centimeter cube after reacting. So here the ratio of these two, that is the ratio of water divided by 50, that is oxygen. You get 2 divided by 5. So 2 divided by 1. That is 51s are 52. So you get 2:1. That can be written as 2:1 ratio. Okay, you get a simple whole number here. That is only says that simple ratio of ratio by volume, provided all gases are at same temperature and pressure. Now we are taking hydrogen gas, which is reacts with oxygen gas. You get water vapors, that is also a gas. This is water vapors or water vapors is nothing but havi anta interval neeravi anta, that is water vapors. You get same volume. Let us assume that hydrogen H into 2, we are taking 2 hydrogens. Okay, half O2, that is 2 get cancelled, you get only 1 oxygen. These two are react. two hydrogens and one oxygen can react together, H2O. H2O. Okay, here the hydrogen is 2 and oxygen is 1. It means one oxygen can react with two hydrogens. Therefore, the volume of water is same as the volume of hydrogen. That is centimeter cube. That is only says that the Gay-Lussac law. So similarly, you take carbon and oxygen or carbon dioxide. Now take one more example. Observe here. One more example I will write here. Carbon dioxide. That is carbon C plus oxygen O2. That gives us to carbon dioxide. Carbon dioxide. So carbon C, di means 2, oxygen CO2. So you get carbon dioxide. Now observe, let's take the volume of carbon is 50 ml, that is 50 centimeter cube, and volume of oxygen take 100 centimeter cube. Why we are taking 100 centimeter cube? Oxygen, either you take 200 or 300, but observe here, the oxygen is taking 2 moles, but carbon is taking 1 mole. Means one element of carbon combined with one molecule, means 2 atoms of oxygen, you get carbon dioxide. Here the oxygen volume is high, therefore after reacting these two you get 100 centimeter cube of water, carbon dioxide. That is only the statement of Gay-Lussac. This is proposed by scientist Gay-Lussac. So it states that when combines means when two gases combine or produces in a chemical reaction, when two gases combines or produces a chemical reaction, they do so in the simple ratio by a volume, provided all gases are at same temperature and pressure. This is the Gay-Lussac law. Now take fifth one, Avogadro's law. So next one, Avogadro's law. Fifth law, Avogadro's law. Avogadro's law. The fifth law is Avogadro's law. This is proposed by the scientist Avogadro. Proposed by scientist Avogadro. So he is the famous chemist. This Avogadro scientist is a famous chemist, and he gives conclusion about how much number of atoms is present in a 1 mole of a substance. ಅಂದ್ರೆ 1 mole substance ಅಲ್ಲಿ ಎಷ್ಟು atoms ಇದಾವೆ ಅಂತ Avogadro ಅವರೇ ನಮಗೆ ಕ್ಲಿಯರ್ ಆಗಿ ಕ್ಲಾರಿಫೈ ಮಾಡಿರೋದು. And after clarifying, he give a number that is called Avogadro number, so that we learn later after knowing the structure of an atom completely. So structure of atom ಗೊತ್ತಾದ್ಮೇಲೆ ಕಂಪ್ಲೀಟ್ ಆಗಿ ನಾವು Avogadro numbers ಬಗ್ಗೆ ಡೀಟೇಲ್ ಆಗಿ ಹೋಗ್ತೀವಿ. Now just listen, the Avogadro law is proposed by the scientist Avogadro. He says that, it states that equal volume of gas should contain equal volume of gases should contain equal number of elements at same temperature and pressure. Same temperature and pressure. This is the statement of Avogadro's law. So listen, the Avogadro's law says that the equal volume of gases should contain equal number of elements at the same temperature and pressure. At same temperature and pressure, the equal volume of gases should contain equal number of elements. Okay. Now observe example. Let's take the formation of water. H2 plus oxygen, that gives us to H2O. H2O. Let's take two equivalents of hydrogen gas and one equivalent of water and get 2 H2O. So after balancing equation, you get 2 H2O water. Now observe at same temperature and pressure, the volume of gases is equal to number of ions. Now take the volume. Let's take one beaker. We are taking a beaker, let's assume this square is a beaker. This square is a beaker and assume ಮಾಡ್ಕೊಳ್ಳಿ, or just write a beaker if you confused. Let's take this is a beaker containing hydrogen. So how many molecules of hydrogen you are taking? 2 molecules, that is 2 H2O. Let's take one molecule, it containing 2 hydrogen atoms like H2. I am writing 2 zeros, it means 2 hydrogen atoms, H bond H. Here there is a 2 hydrogens. I will write the hydrogen cases only. Hydrogen. So these circles is what? Is hydrogen. I am writing like that. And this reacts with oxygen. Let's take oxygen. Oxygen. Now you have to take equal number 4. Because at same temperature and pressure, equal number of molecules is present. Means elements is present in given temperature and pressure. Now I am writing only one hydrogen. This is H2. This is O2. Here there is 2 H2. So you should write one more hydrogen. That is, take this third one. This is hydrogen. Here one hydrogen. Here one more hydrogen. So here also there is 4 hydrogen molecules like that. 4 hydrogen molecules. Now these 4 hydrogen molecules combined with the 4 oxygen molecules means 8 hydrogen molecules and 4 oxygen molecules.